Okie dokie, okie dokie. Okay, I don't have that exam, has it? So once I find where the heck did I put my pen?
No, I know how to get the question, but the question like said, what is in a form?
Yeah, that's fine. Help me, students. Where's my pen? Oh, here it is. Right. So you just need help with the last step, changing the answer, is it? Okay, so what answer did you get?
36
Yeah?
minus 22 equals 8.
Huh? Oh, okay. Sorry. Yeah, but what, okay, that's great, but
Yeah.
what's next?
So the answer is bigger than 2. It's bigger than 0, so it's going to be 2 roots.
Yeah?
So how to get the 2 roots?
But what was the question, though?
Now the question is y equal
Okay.
x squared
Yeah?
plus 6x
Yeah?
plus 7.
And what do they ask you? What do they ask you there?
I think find the discriminant.
Yeah?
Determine how many
Possible 2
solutions.
roots.
Ah, find the discriminant and the possible 2 roots. Okay, so the discriminant is b squared.
It's not changing.
Oh. Sorry. There we go. B squared minus 4ac. Yeah? We're all right with that?
Yes.
Yeah. That's 36 minus 28, isn't it?
Yes.
Which is what you said, which is 8. Now, and you're right, has it therefore 2 roots because it's more than 0.
Yes.
If you want to use the discriminant to get the roots, you can use this fact next, that the roots are minus b plus or minus the square root of the discriminant all over 2a.
Which video you mean? From
The original. The original, yeah. So, that will be x equals minus 6 plus or minus root 8 over 2a, which is 2.
Negative 3 positive. Square root 2.
Sorry, what's the first one? Negative 3?
Positive.
Yeah.
Plus square root 2.
Not over anything? Ah, so then the other, of course, yeah. So the other answer would be minus 3 minus root 2.
Yeah.
Yeah?
Can you show the last one?
Sure. Triangle, sorry, as my symbol I use for discriminant. Perhaps Joan uses a capital D? But does she not use a symbol for discriminant? She just says b squared minus 4ac?
Yeah.
Yeah, okay.
She just gives us the formula.
Yeah. Yeah, sorry. So if you want, for me, okay, I would say discriminant, which is my triangle here, is b squared minus 4ac. I write this for short. I assume you all know the formula for discriminant, yeah? B squared minus 4ac is called the discriminant, the delta symbol I use. Or some people use capital D. Yeah. Okie dokie, happy with that? You all have that? Haza?
Yeah.
Yeah. You said you have a question, you want to see number 10, is it? Yeah. Okay, let's have a look. Can I scroll down? Yeah. Okay, read number 10 to me, please, since I don't have it. Read number 10 to me, since I don't have it.
Show that the GP is divergent and find the sum of the first 15 terms. That's 15.
Okay, and what's the GP?
Negative 3,
Yeah,
9,
yeah.
negative 27.
Yes.
Right. This is called a GP, geometric progression.
Yes.
What's the A?
Negative 3.
Good.
Yes.
And what's the
Minus 3.
OR is also minus 3. How do we know it's divergent?
Well, it doesn't have a limit.
Yeah, and how can we know this? You're correct, it doesn't have a limit.
For
Or
me.
more than 0.
Ooh, not this. Thought you were going to have
This
it.
is for limit, I guess. It's
No, he's close. He just has the wrong number.
A
Or it's more than 1.
That's it. If the or is,
absolute.
if the absolute value of or is more than 1,
Yes.
in this case the absolute value is more than 1. 3 is more than 1. So that is the reason why it's divergent. It's divergent because or is more than 1. That is, the size of minus 3 is more than 1.
Okay.
Yeah?
Is that only the answer?
Mm-hmm.
It's not that.
Huh?
It's not the answer.
Well, I mean, that's half the answer. The next part is the next part is they wanted the S15,
Yes.
Yeah, yeah.
which is A 1 minus or n over 1 minus or,
Yes.
isn't it?
Yeah.
For GP. That will be minus 3, 1. Now, please, when you're typing this in, be careful with the brackets. 1 minus bracket minus 3
But
power
you can put plus.
plus where?
1 plus 3.
Mm,
negative and negative, positive.
Yeah, only because it's a 15 here. If it was a 16, you couldn't. So it best avoid that danger and just put in brackets. 1 minus minus 3, and again I'll use brackets. Right, so when you get a chance, bash that in.
It's gonna be negative 1, 0,
Negative
1, 0,
1 0
7, 6,
7 6
1, 6,
1 6
8, 1.
8. Are you sure? Oh, because the 15. Oh,
14. No, sorry, it's 15.
yes. This is terrible for you. You're going to have 3 hours of me this morning. This is terrible, isn't it? Like, what a terrible way to start Monday. It's cold and you have 3 hours of Stephen. Right. Tell me when you have that copied. Oh, sorry, it's getting a bit cut off at the edge there, isn't it? Let me move the projector. Oh, it's not quite fitting. That'll do. Okay, what's next now? Yeah, which one? Yeah, once. Can I scroll down, has it?
Yeah, yeah.
Yeah.
Okay.
Shall we look at 5 now? Okay, what's number 5?
Express the. Yeah.
Yeah, that'll be easier, thanks. Ah, yes, we just want to expand this. Root 3 plus 2 root 11, 3 root 3 minus root 11. Okay? So, the first one is, now you can use your calculator for this part, it's going to be root 3 times 3 root 3, isn't it?
That's
Yeah.
gonna be 9.
And we could work that out in a moment, yeah. It'll be 9, correct, yeah. Minus root 3 root 11 plus 2 root 11 times 3 root 3 minus 2 root 11 root 11. Now each one of these individually you can type in on the calculator, or as long as you write this step down in the exam. So your right has it, that's a 9. This one, root 33. This one is 6.
Root 33.
Yeah, and then this last one is 22.
So
Yeah.
another question.
Oh, just 1 second, let me just do one last line. 9 minus 22, what's that, minus 13?
Yeah.
Plus 5 root 33. Okay, what was your question? No.
How did you get the 5?
How did I get what?
5.
6 root 33s minus 1 root 33 leaves me with 5 root 33s. You know, I have 6 of them here and I take 1. Leaves me with 5. Who's texting me? Maybe it's Joan. No. Now, what do we want to see next? We can do workbook, we can do worksheet, whatever you have trouble with. Now, I know you must have had trouble with something.
I have one from the graph.
Yeah, graph lesson.
Yeah.
Can I ask business students?
Yeah, I got to do that.
You have graph question too? Business students. Business students. Have you, what was the last lesson you did in Joan's maths class last week on like Friday or whenever?
Trigonometry. Yeah, trigonometry.
Sine cosine rule?
Yeah.
I think maybe it'd be better to do this one next week because they haven't done the graph yet.
Okay.
Were there any questions from sine cosine rule?
Yeah, I have nothing.
Good, okay. Hazza, how's your sine cosine rule? We'll do an example. It's good? Okay, then you can tell us what to do. So, right, which one do you want me to have a look at? Which number? Number 5. Okay. A triangle. Is this, you all have this worksheet here? Yeah? Do you, no, I'll write the question down because John did it with
Can you
them.
find this in Moodle?
I don't know if John put it on Moodle.
Something-
Sometimes she does.
Yeah, something.
I don't know. You can make a picture on your phone if you want a copy of it later. A triangle ABC is such that AB is 2 centimeters longer than BC. Okay, let me draw the triangle. So, A, B, C. Now, listen carefully. I'm not saying AB is 2. A triangle ABC is such that AB is 2 centimeters longer than BC. The angle at B, that's here, is 60. The length of AC is root 39. Now, they tell you to call BC X. So what would AB be?
We're gonna make the Pythagoras theorem.
No, because we don't know if it's 90.
Or the triangle.
Perhaps, or perhaps cosine, we'll have to see. I'd say maybe it's sine rule. Oh, I'm not sure actually. Maybe cosine rule maybe. Anyways, what length is AB? Now listen again. AB is 2 centimeters longer than BC.
So AB equal
Yeah?
2x? No.
No?
2
Yeah.
AB equal x.
No?
Why? Because it's CB.
No, listen. AB
Yeah.
is 2 centimeters longer than BC.
Plus 2.
With the full.
So AB equal
Yes.
x plus 2.
There we go. X plus 2.
So how can I know if it's like plus or times?
Yeah, so what's the English difference? Here, AB is 2 centimeters longer than
Double.
BC. She wants to know, how would you know it's not times? What words would they say?
Longer?
Double?
Multiple.
Yeah, they could say multiple, they could say double, or they could say, what's another word? That means double.
5?
Yeah, but begins with a T.
Twice?
Twice, yeah.
Yes.
Yeah, okay. Here, longer always means plus. See, because you can never, I don't think, maybe I'm wrong, I don't think in grammar you could ever get the word double or twice with the word longer in the same sentence. Like I couldn't say it is double longer,
No, twice long.
or could you say?
Twice as long.
You could say twice as long, you don't say twice longer. I think. I can't think of any sentence where I could make the word longer and twice or double in it, right? It doesn't sound right.
I can't either.
Yeah, so I think if you see the word longer, you're safe to say it's a plus, not a multiply. Okay. Anyways, this is probably grammar you don't do in EAP class. I don't think you'd be talking about this type of stuff in EAP, longer or...
We don't talk about that, but we
Like
focus
maths?
on grammar.
Yeah, but would it be maths grammar?
No.
No, I didn't think so. Yeah, yeah. Okay, so what rule do I need now?
The cosine.
Sine.
How did you know that the square root or anything is like the hypothesis?
Okay, one at a time. So, firstly, cosine rule. You're right. Who said ever said cosine? Because you can't really use sine here. You don't. You could use sine if you knew another one of these angles.
Yeah.
It would work. So it has to be cosine. Because remember, if you can't use sine, then really it has to be cosine.
But how can I know it's it's cosine?
Yeah, it's cosine if you can't use sine. And to use sine here, I need to have another angle. Or I need to have another side.
Oh, yes.
Yeah. Now, you were asking me something, Hazel?
How did you know where's the hypotenuse?
Oh, I don't know which one is the hypotenuse for sure. My picture might be wrong. It's possible that maybe this side is the longest. I don't know. But you needn't worry, because with the cosine rule, it doesn't matter. It doesn't matter. So it'll work out okay. But you're right. It's, you know, okay, well, I know for certain the x can't be the longest side. Why? Why do I know for certain the x can't be the longest side?
Because AD is
It's too longer, yeah, so it'd be quite amazing if somehow x was the longest side, right? But, I mean, it's possible maybe the root 39 was the longest side. Okay, so for the cosine rule, we have some choices to make. Well, no, actually, I don't think we have a choice. We have to start... Yeah, we have to start with one of the sides in the formula. Which side do I start with?
The x.
That's what I thought at first, and then I realised it doesn't work because you don't know the angle over here.
Root 39.
It has to be the root 39 because it's opposite the 60. So root 39 squared is 39. That's equal to x squared plus x plus 2 squared minus twice x plus 2 cos 60. That's the cosine rule.
Wait, so
Yeah.
do you just remove the roots?
Yeah, because I squared it. So it was originally like this, root 39 squared, which just becomes 39. Yeah. You can write it like this if you prefer.
What lesson is this?
It's a maths lesson. Sine and cosine rule.
Oh.
Why is like if I choose cosine 60
Mm.
equal x over root 39?
Because we don't know if this is 90 degrees. We don't know if it's a right angle triangle.
If it was a 90 degrees, then you
Then we could do something like that, yeah. Yeah. This is the advantage of the sine and the cosine rule. Works for any triangle. Whereas those rules you mentioned has it, like Pythagoras and that formula, is only for right angle triangle. You know what I mean when I say right angle? Yeah.
But the last time you told me that cosine only worked for SAS and SSS.
Let's see, I said SAS and SSS. Okay, S side, angle,
Sorry.
side. Side, angle, side. Yeah, this one's a bit weird because... What the heck are you doing here?
Can I just skip Joe or something?
Okay, be quick. You don't want some extra maths?
You
Okay.
don't need extra math.
See ya. Yeah, do you know what? This one's a little bit weird because I kind of give you a side angle side because you have this side for sure, and you have this angle, but it's so weird because you kind of have this side, but not really. But I tell you, it's too longer than this. It's a very strange example. But you know what? Look, okay. Let's say you were totally confused and you didn't know if it's sine or cosine rule. Well, look what happens if you try the sine rule, okay? You start off with saying sine 60 over what? Sine 60 over root 39. equals sine, we could pick this side, A or C. Which do you want to pick?
A.
Sine A over
X.
x. Now, do you see the problem? How many things do we not know here?
2.
We can't solve it. But if I use the cosine rule, how many things do we not know?
2.
Which two?
X plus 2 and X.
Yeah, but x plus 2 and x is x in both cases. Do you know what I mean? In both cases, you don't know x.
Oh, yeah.
Yeah. So, you can, if you're never sure, my advice is try the sine rule. If it doesn't work, then it has to be the cos rule. Simple as that. Okay, anyways, what is cos 60 now? It's a half, is it? No. Or the root 3 over 2.
Yeah.
1 over
That's nice. That's nice. Can you see? Because if cos 60 is 1 over 2, and you have a 2 here, what can you do?
2 over 2.
Delete that.
Yeah.
Yeah, delete.
Because this is like Haza if you have 2 and then 1 over 2.
2 with
2 with 2, yeah. So let's expand. That's 39 equals x squared. Who can expand this quickly for me? What do you
2.
get here?
Squared plus 2x plus 4.
Plus 4x plus
Plus
4.
4x.
Nearly. Minus, and let's expand this one. Minus x squared minus 2x. Yeah?
Yes.
Now this is nice because what cancels now? Or it doesn't cancel. X squared plus x squared
2x squared.
minus x squared.
X squared.
4x minus 2x.
2x.
And then let's bring the 39 to be with the 4. 4 minus 39 is minus 35. Okay, can we factorize this? I think we can. 7 and 5.
Yeah.
Yeah.
The answer is only 5. Why is the other answer no good?
Because it's a negative.
Can't have minus 7 as a length. Does that answer it for you? Oh good, I have it right.
Can you zoom out?
Yeah. Yep. Yeah.
I have a problem with the first one on this paper.
The church one, is it? Yeah. We'll do that one next. Yeah. That's a good type, a good exam type of question. You know, I've seen this type in the exam many times. So it'll be good to make sure we can do this one. Can I scroll down? Yep.
Yep.
So look, I don't even have to read the question. This question is so common, I know the way they set it up. You have the ground, you have a building here, it has some height, you don't know the height. Somebody looks at the top of the building at a particular angle, and then they walk closer and look at a different angle. And we know these angles, I'm sure. What's this angle?
This angle is 30 degrees.
And the closer angle?
34.
And the distance the person walked
22.
from here to here is 22 meters. Now I'm going to do this one. This, again, I'm going to say it again, this is a classic exam question. I've seen it, you know, I don't know, 5 times. It's a classic, okay?
These numbers are like already there.
Yeah, the red numbers are provided, and then what I'll do, can everybody see this is green? You all see it's a different shade to red. Nobody's colourblind, it's all okay. I'm going to shade in green the information we work out, okay? So I think the first thing to get that would be easy is this angle. I can work this one out.
Yeah.
By what?
180 minus.
That's it. So here we get
146.
146.
1, 4, 6. And now I can get this angle.
30 plus 146.
I think it's like 4.
4.
Yes.
And now I know this is 90, so I can get this angle. Because this plus this makes 180. So 180 minus these two, 56. Now I have all my angles. Okay, what I'm going to do next. So my tip for these questions is it's always good to work out the common side, this one here. I'll have to give it a letter. Let me call it X for the moment. So, using your imagination, just look at this triangle on the left. What rule could I use to get the X?
Cosine?
Good, cosine. So let's begin cosine. Cosine, no, oh no, sorry, not cosine. Sine, yeah. So you can say X over sine,
30.
good, equals 22 over
4.
sine 4, good. So I'll divide, or multiply.
Times.
Yeah, that's it, 22 times sine 30 all over sine 4.
Negative.
Negative, oh, we can't have a negative length.
Negative 5.5.
No, impossible. Impossible. 22 sine 30 over sine 4? I'm expecting an answer like 30. Somewhere around here.
Negative 1.
No, impossible. Impossible. What is it?
3.0.
Oh, that's too small. What? 156?
Is it 22 over sine 30?
No. Don't break my heart. It's 22 times sine 30 all over sine 4.
It's 157 point.
It's really that big? Okay.
0.75.
What?
Where is your sine 4? You're just typing 4. What is it?
157.7 because it's 0.69.
Yes.
Okay. Yes. Right. Now, Hazza, do you see this triangle here is a right angle triangle?
Yeah.
So now we could use one of those rules earlier. So tell me, we are looking at H. What's the relationship between H and the angle 34? Is it opposite, adjacent, or hypotenuse? Good. And the X?
Adjacent.
No.
Hypotenuse. So which rule do we need if we're talking about opposite and hypotenuse? Very good. So you can say sine 34 equals H over 157.7. We just said that's the X. We worked it out.
Oh, okay.
Yeah. So H will equal 157.7 sine 34. Whoops, there we go. What do we get as our final answer?
88.2.
Thank you.
Can you repeat the last step?
I'm just using sine equals opposite over hypotenuse.
Oh, okay.
How did you get these degrees?
Which one?
The 146 and 4.
The 146 is because here must add to 180.
Yeah.
And we know that this is 34. So 180 minus 34. You're looking a bit confused.
Why like we didn't use the 30?
The 30?
Yeah.
I did after that because 30 and 146 is 176. And these triangles here must add up to 180. So it means this guy must be 4.
And 180 minus 34 is 146.
180 minus 34 is 146, correct, yeah.
Then 146 plus 30.
Is 176
Yeah. Then we add the 12.
to make it 180. Yeah.
Then the square is 90 degrees.
Correct. And 90 and 34 is 124, which makes this guy has to be 56 then. Because this, and this must be 180 as well.
Oh, okay.
So it's step by step by step by step. Is that the answer at the back for this one?
think they rounded it.
They rounded it differently.
Yeah.
Yeah.
What's the answer at the back?
The first one's 158.
158.
Oh yeah, so they rounded this up to 158. Yeah, and does that affect this answer much?
No.
Just 88.
88.
Just 88. Okay, so that would be 157, and that would be 88. Okay, fine. Is this okay for you? This one? And Haza?
Yeah.
Is this okay for you? Yeah. Right. What's next? Book, which lesson? Trig equations. Business students, have you done the trig equation lesson with Joan? What page is that?
64.
64. Have you, no. What page did you stop on?
58.
58. Okay, we. Yeah, they're only on page 58, so I don't want to do this because it's only going to be for you two. So any questions up to page 58? Too easy?
5.
What page?
58.
Okay. Can you open page 58? So what's number 5 about?
No, wait. We
No,
have,
wait.
Like different pages. We have this. Yes, this one.
Are your page numbers different, is it?
Yeah.
So what page is it for the business students?
56.
56, okay. 56 for the business students, 58 for the science students. Which number?
5.
5 part
A.
A. So what's the question, 5 part A?
Sine,
Yeah?
cosine, inverse 4/5.
4 over 5. No calculator for this one. Have you seen this one, business students?
Yeah. But we use calculator. But we use calculator.
You use a calculator, and did Joan allow this?
I don't think we did this one. I think we just did up to 4. I'm not sure.
Okay, well let's...
Did we do up to 4? Did we?
Yeah, I use calculator.
Well, the science students will tell us what to do. Go on, Hazza.
We draw the right angle.
Good man. Draw the right angle triangle. Business students, are you watching? Especially if you haven't done this. So first you draw the right angle triangle. Okay, and then, yes, what's next?
Cosine is adjacent over hypotenuse.
Good. Cosine is adjacent. So that side's adjacent and that side's hypotenuse.
Yeah.
So here, this is 4, and that's 5. Yeah?
This is the
And then Pythagoras tells us
3.
3. And then Hazza?
Then we use the sine.
Sine, finally.
Yeah. Opposite of
Oh, yeah, yeah. you remember.
Which in this case is?
the 3 over. No, 3 over 5.
There you go. That's the answer. Did you all get your mid-semester result? Yeah. Right, what do you need to see next?
I just have like, but we didn't take it. Yeah. First derivative.
Oh, that's that's far too far ahead for them. I think their book is slightly different because they just have semester 1 in their book. Whereas you have both semesters, yeah. Not that it matters, but I think this is why the page number is slightly different. Because their table of contents is smaller, it means their number starts sooner.
Well, I didn't know if I have asked you this.
Which lesson?
Sequence and series.
Yeah?
8.
Oh, 8's not on the exam. It's extremely... Is it number 8? Can I see? I'll just make
Yeah.
sure. Yeah, 8 is never going to be on the exam. It's too advanced. Yeah.
Because I couldn't. You can see I'm trying, but I couldn't.
Yeah, yeah. 8 is only for people like Matar. That's why I put it in the workbook. To keep students like him busy, you know? Right, what do we need to see next? Don't be shy. What's next?
I have a question,
Yeah?
but it's only the last step.
For which?
It's from the midterm test.
Fine, yeah.
Yeah.
What question is it?
It's number 4.
Which one's that?
We solve the inequality.
The inequality, that's a short one. What's the inequality?
Minus 17.
Minus,
17.
yeah,
Uh,
less than, yeah.
Or equal to minus 2x.
Yeah.
Plus 7.
Plus what?
7.
Yeah.
And, yeah. 5.
Now, before I begin, does the question say anything about how I want the answer? Like, does it say find the set or find the...
Yeah, there is, I think, the...
Yeah, give your answer in set notation form.
Perfect, perfect. Right. Business students, how did you learn to solve this?
Subtract both sides.
Well, I'm just wondering what the business students did.
So we did like this side first and then that side.
Oh, Joan didn't show you any other ways?
Didn't she show us a way where you have to like subtract it by both sides?
Yeah, that's what I'm talking about. Right, so I'm going to use that way. It's a little quicker. So, subtract what from everything?
Minus 7.
Good, minus 7. So that will become minus 24. Hey, you're bringing us heat.
I'm bringing in the heat.
Great.
Sorry, I'll be back. Out here in a moment.
Where's the cold spot? Probably by the open window.
Probably, yeah.
Yes. Thank you. I don't know why that's open.
Because nobody closed it, I guess.
I suppose, but why would anyone open it to begin with? The larger question.
Right.
Right, I'll see you later. Now, what do I have in the middle if I take away 7?
Negative 2x.
Good, and at the end?
Negative 2.
Very good.
Divide by 2. Negative 2.
Divide by negative 2. So this becomes 12
And 2. And 1.
x.
1.
1x, yeah. And this one here?
We have to
One.
switch
Why do I have to switch?
because we divide.
By
Oh, finish the sentence. We have to switch because we...
Divide
by
everything
negative.
by negative 2.
By the negative 2. Negative is why we switched it. Because if we divided by 2, we wouldn't switch it.
Yeah.
Only because it's negative 2. Do you not do this? Yeah.
So,
So, how about...
do we need to flip?
12 is greater than or equal x.
So yeah, if you look... How? Oh, sorry, I never flipped it. Sorry, my brain is a bit cold. Sorry, I never flipped it. Here and here. Right.
Only by if it's negative 5.
Yeah.
Yeah. Yeah. So look at what I wrote. X. Is x bigger or smaller than 12?
Bigger. Smaller.
Smaller.
Smaller. And is x bigger or smaller than 1?
Bigger.
So you want x to be bigger than 1
That's smaller.
and smaller than 12.
Yeah.
And do we want to include the 1 and 12 or not include
Yes,
it?
included.
Include it because of the equals here.
Sign.
So this is how you write 1 to 12 including 1 to 12. 1 with a square bracket, comma, 12 and a square bracket.
What about 1, 2, 3, 4, 5?
No.
Why?
Yeah, so now my question, how did we know, like, which form do we use?
The question said set.
Notation.
So that's like this.
The one, like we put 1, 2, 3 to 12.
Yeah.
That's only if x is a natural number. You see, if you just say x could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, what about 1.5? Is 1.5 an answer? It is, because it's bigger than 1 and smaller than 12. But did you include 1.5 in your answer? No. So this is why 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is not the right answer. Because you're missing all the numbers in between 1 and 2, and 2 and 3, and 3 and 4. Does the question say x is a natural number? Does it?
No.
No.
X is rational.
A real number.
Real.
Real, yeah.
Z is rational.
That's it, yes. Let me remind you of the sets to help you.
Yes, please.
So, n means natural numbers, which are numbers like 1, 2, 3, 4. Z? What's Z?
Integers.
Oh, say again.
Integers.
Oh, not quite. Integers.
Integer.
Yeah, and what are those numbers? Business students, do you know integers? What are they? Business students, do you know what integers are? What numbers are those? They're numbers like 1, 2, 3 and minus 1, 2, 3. They're positive and negative natural numbers. Okay, what is Q? Q? Okay, Q are what's called rational numbers. What numbers are those?
Square root 2.
No. Rational
2.5?
numbers? Yeah, so they're fractions.
Yes.
They're fractions. And lastly, or is, what's or
And,
called?
Real numbers.
Real numbers. And what are those?
All numbers.
All the numbers.
Including.
So in this question, you assume x is real, unless they tell you something else about it. This is what you might call the default. Do you know what I mean by default? What you normally do, unless they tell you otherwise. So because of that, we say this is the answer. Okay, yeah.
When can I use that, like the curly bracket?
That's only if I tell you at the beginning x is a natural number or an integer. You guys look confused. Did Joan not show you these symbols before for sets?
She did.
And you forgot them? That's okay.
Yeah, kind of.
This was a bit of a refresher
The
then.
integer.
Yeah, okay. Right, well that nicely wraps us up then for this morning, okay? Do you have Joan later today?
No.
No, okay, so you're not affected for the rest of the day then, so. What room are you in? Still here?
Yeah.
Okay.
Yeah.
And we're up in D now, isn't it? Ah, okay. Can I close this?
Yeah.
Yep.
By the way, is that a drawing tablet?
It's a very basic one.